would just like to welcome you to pre-algebra, and on behalf of the entire math department, we hope you will love the delivery of this course. We have tried to tailor this course for your interests and your learning styles, and you can work at your own speed. So if you want to watch the video at a slower pace, fine. If you want to watch it 5 times, that's great. If you want to watch it once, that's fine too. So you can work at your own pace, and you'll always have your instructor by your side. We hope you take this time or this opportunity to fix all the holes you have in your math education. This is the time, pre-algebra, when we start with fractions and decimals and percents, all those things that you love, we're going to make sure you get them this time so you can move off to your next course with an incredibly solid foundation. You'll have a workbook that accompanies every lesson you have, and you'll see a bullet mark like this, and with the bullet, it'll tell you that there's examples to be solved, and then the workbook itself is hole punched, so that I hope you will buy a binder and put those pages in the binder and have extra paper to stop the videos often to take notes, because those will be your baby. The notes is the key here, because you have only the workbook, not a textbook. It's going to be really important to take your own notes. So between the videos and the notes that you take and the questions you ask your instructor or the other students in the class or in other classes and the study groups I hope you will form, you should be successful in this course. So let's get started. I hope you enjoy the ride. What do you think the first number you ever learned was? Well, I think it might be the number 1, because you probably wanted to tell somebody your age. And then you probably wanted to start learning how to count. So I think it was the numbers 1, 2, 3, ... That ... means that this set goes on forever without end with this pattern. That means to go from one number to the next, you have to add 1. These are called the natural or the counting numbers, and they have a symbol of an N. Then you went to school, and you were so excited to be there. And your teacher put a problem on the board and said, fill in the blank to make a true statement. And you're thinking, well, I got this, because I know my numbers. I have 1, 2, 3, all these numbers. And you start thinking, oh my gosh, none of these numbers fit in here. What am I going to do? All of a sudden, a little bit of math anxiety develops. But it's okay, because we have another number, the number you need. So we have a new set. This new set is called the whole numbers. In this new set, you have the 0. Now, so it takes this set and adds the 0 to it, and you have this new set, ... Again, it goes on without end. And it goes up by 1 from one number to the next. And again, notice the name of the set, whole numbers. The symbol is a W. When you say whole numbers, your lips actually make a 0, which kind of reminds you that 0's in that set. So I know this is kind of corny, but whole numbers. See, I made a little 0. It's kind of clever. Anyway, so you have the natural numbers and the whole numbers. Notice there are numbers not in either of these sets. That would be your fractions and your decimals and your negative numbers. They are not in that set. So I want to show you the relationship between the natural numbers and the whole numbers. So remember, all of these numbers are real numbers, so that's what this represents. And now I have the natural numbers, but remember, some of the natural numbers are 1 and 2, and obviously there's an infinite set, so they won't all fit there. But remember, then we needed the 0. Okay, so if we put the 0 in, remember that set was called the whole numbers. Now notice the natural numbers have the 1 and the 2, but does not contain the 0. Where if I take this off, I can show you that the whole numbers are the 0, the 1, and the 2, okay, because they encompass the natural plus the 0, okay? And all of these numbers are the real numbers. I hope now you understand the relationship between the real numbers, the whole numbers, and the natural numbers. The sets we have covered so far are in your workbook. Just make sure you take note of that. And now we're going to just look at some bigger numbers. It's time to play with the big boys, you know? Okay. So let's take a look at this number, 2, 4, 5, and this number, 5, 4, 2. Notice I didn't say what numbers those are yet. I just want to say something about this. In math, we deal with a place value system. And this is called a place value chart. And this place value chart breaks our number system up into periods. So this is the ones period. That's why they're different colors. The ones period, the thousands period, the millions, and the billions. I want to tell you a little story that really did happen to me. When my daughter was a kid, I used to give her these problems in the back of our car to do, and of course they were verbal. I'd say, you know, add 20 plus 8 for me, and she could do it. And when she went to kindergarten, she said, you know, the math's too easy, Mom. Make them give me more problems, harder problems. So I called up her teacher and said, hey, give her harder problems. So she got a worksheet one day, and they were all problems like this. And she got every one wrong. And the reason she got every one wrong is not because she can't add 26 plus 8, but because she did this. 6 plus 2 is 8, plus 8 is 16. So she got the answer 16. Obviously, that's wrong. And that was wrong because she didn't understand that there was a place value system in math because she had never seen this done on paper. So we're going to be a little smarter than that. And I'm going to make sure I tell you that there is a place value system, and this is how it works. This number 245, we can put in the place value system. Going from right to left, we start with that last digit, 5, 4, 2. That tells me there are 2 hundredths, 4 tens, and 5 ones, which makes this number 245. Notice I did not say and, because if I say and, that means there's a decimal in the number. So this is the number 245. Let's take a look at this other number. If I do the same thing, I'll do this with a different color so that you don't confuse the two. Oh. Starting from right to left, we get 2, 4, 5. This number has 5 hundredths, 4 tens, and 2 ones. So this is the number 542. Now the question is, are these numbers natural, whole, neither, or both? Well, let's take a look at this. 245 would be in this set if this set continues without end, as it does. So this is a natural number, but notice it's also a whole number, because if we continue this set without end, that number will also be in there. Same thing with 542. It would be in this set because it continues, and also this set. So the answer to that question is they're in both sets. We want to write the number in words. To write the number in words, we write it just as we see it in the place value. So 245 would look like this. 200. Now I know you probably want to put a comma there, but don't put a comma there because there's no comma in the number. So it's 240. And this is called a hyphen, 45. I know I have a hyphen when there's a 2-digit number. 45 is a 2-digit number. This number is 500. Again, don't put a comma there. 42, and there's your hyphen. So that's how you write the number in words. Now we want to know if this statement is true or false. This is a new symbol. This symbol is equal to. I know you all want to say equal to, but it's really important that you have the word is there, because this is called a comparison symbol. It's comparing 245 and 542. The is so important that I'm going to make sure you see it really big whenever we have a comparison symbol. So this is equal to. Well, 245 equals 542 is a false statement because it is not equal to. This next problem is actually in your workbook, so let's take a look at it together. These are the digits that you'll see. Now that looks like a pretty long number. That's kind of scary, isn't it? All right, I'm going to take this chart, liking the colors there. All right, again, I'm going to do it from right to left, put those numbers in here. So here's a 1, a 5, a 4, 0, 0, 4, 3, 9, 0, 7. Now we have to put commas in so we can read this number. Okay, so you have to put the comma in after every 3 going from right to left because that's where the new period begins. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Now here's how this works to read it. To read it, you take a look at the number and you say the last number it's in. Okay, so it's 7 billion. So we have 7 billion. Now there's a comma there, so we put a comma there. Then we have, let me make this a little clearer for you. Then we have in these 3, in this period, the millions column, 93, so it's 93 million, but 93 is a 2-digit number, so it gets a hyphen 93 million. And now there's a comma there, so we put a comma here. And now this next set is 400,000, because that's the last number there. That's the period. 400,000. 400,000. And then there's a comma, so you put a comma there. And this is 451. Obviously, you don't say 451 ones. You leave out that period name. So it's 451. And 51 is a two-digit number. Therefore, you put that little hyphen there. Notice no comma here because there's no comma in here. And that's how you read and write numbers. So it's really important to make use of this place value chart, okay, because that tells me how I can read these numbers real easily. This question has separate the digits into periods and name the place value and write the number in words. So let's take a look at the first number. 213656764. So we're going to do a lot of things with this number. Again, I'm going to move this over. And again, you have this in your workbook, so I'd make good use out of it. Okay? And again, I'm going to put my digits in from right to left. And we have 4, 6, 7, 5, 6, 3, 2, 1. 2136567. Always check that you have the right digits, because if you're like me, you may be a little blind. Okay, then count after every 3 digits. 1, 2, 3, comma, 1, 2, 3, comma. So now, quite easily, I could see in my blue period of millions, I have 21 million. Comma, because there's a comma there. 365,000. $65 is a two-digit number, so it gets a hyphen. 65, the 5 ends in 1,000, so that's where your 1,000 comes in. Comma, 764. Okay. Now, for the second part of that problem, we want to tell you what place value the 2 is in. So the place value for the 2. Well, just go to the 2 and look at the place value. It's 10 millions. So the place value for the 2 is 10 millions. No, I shouldn't have put a hyphen there. So it's just 10 millions. I'm going to do that one more time with another number, but it takes this place value chart takes very big numbers and makes them easily accessible through the chart. Okay, so let's try this next number. In fact, why don't you stop the video here and try this next one yourself. Okay, so let's see how you did in trying that problem. Let me clean this up. This is a handy-dandy little board. You can make your own, you know. All right, here we go. This next one had the digits 90020500. Okay. Again, putting these digits in from right to left, we get 0, 0, 5. There are a lot of zeros in there on purpose because it's harder. Okay. Of course, I let you do the hard ones. That's the rule. I do the easy ones. You do. Oh, I missed a 0, didn't I? All right, let's put that 0 in there. Okay, 5, 0, 2, 0, 0, 9. Let me just count. Make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. Not a bad idea to check yourself. Okay, now let's put the commas in. So after every 3, going from right to left, 1, 2, 3, comma, 1, 2, 3, comma. Okay, so now let's take a look at this number. This number is 900 million. Comma, because there's a comma there, 205,000 now there's another comma. Oh, 1,000, that's it, because 0, 0, 0, 205,000. Now the rest are zeros, so you don't write anything else. So 900,205,000. And notice no and. I know you want to say it. I say it all the time. Don't say it. It means there's a decimal in the number. So that's the number. Now we're going to figure out what place value the 2 is in. Okay, let's find the 2. There it is. And it's in 100,000. So that's the place value of the 2. Okay, I hope that was easy. I hope you did fine with that one. Of course, there'll be more practice later in those. Okay, the next thing we're going to look at is another way to write that. We've gone from digits, okay, to saying them and writing them. Now we're going to go the other way. I'm still going to use this because this becomes a really important tool for these examples. Okay, let's look at the first number. The first number says 20,005. Again, look, no and in that number. 20,005. Okay, I find this the easiest way to do it. 20,000 means that the 0 in the 20, because it's the last 0 in the 1,000 period, has to be under the 1,000. So there's your 20,000. 5, that means there's no hundreds, no tens, and there's 5 ones. So there's your 20,005. And there's your comma. So that's the first one. The next one is really hard. The next one is 8,008,838. That's a huge number. Let's look at that one. So I'm going to do, to not make you confused, I'm going to erase this. Let me try it again. Here we go. So let's go piece by piece. I'm going to wait for the comma. So it's 8 million, and then there's a comma. So 8 million means there's 8 in the million spot. 8 million. 8,000 means there's 8 in the 1,000 spot. And then it's 838. 838. There's your 838. Well, look at all that space between here. Well, obviously that means I have to put zeros in there. So there's your 8,008,838. And here we go. We put commas in. 8,008,838. And that's called standard form. Standard form is taking it from the words to the digits. Okay, now we learned about standard form, so we learned how to read them, how to write them, how to put it in standard form. Of course, there's always more. So the next thing we're going to talk about is expanded form. In expanded form, you really have to understand these different place values. Okay, let me give you an example. The first example is 6,789. Here comes expanded form. Well, this is 6,000, so 6,000 plus 7 hundredths plus 7 hundredths plus 80 plus 9. 6,789. That is expanded form. Okay, notice something that's kind of a trick. I don't really like it, but you should notice this. Is notice that when we write 6,000 here, there's a 6 and then there's 3 digits. Notice there's 3 zeros. Okay? Notice with the 700, there's a 7 followed by 2 digits. There's your 2 zeros. The 8, and there's 1 digit, so it's followed by 1 digit. But it's 6,000 because 6 is in the thousands place, 7 is in the hundreds place, 8 is in the tens place, making it 80, and then 9. 6,789. Okay, now we're going to look at the next example, but stop the video here and do the next example yourself and put it in expanded form. Okay, let's see how you did with that problem. Okay, the digits you had to work with were 2, 3, 4, 0, 0, 7, 8. Okay, you might want to put it in your little place value chart that you have in your workbook. Let me straighten this out a little bit. Okay, so we have 8, 7, 0, 0, 4, 3, and the 2 here. So that's 2,340,078. Now, let's put that in expanded form. Okay, that was our old example. Okay, here's what we got. We got 2 million. Now, I have to show you just the little trick is to count how many digits you have left. 1, 2, 3, 4, 5, 6. That's how many zeros you're going to have. So there's your 2 million plus 300,000. So 3, count your digits here. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. And then you have 40,000. So plus 4, 1, 2, 3, 4. And there's your 40,000. Then you have 0 hundredths, which you do not have to write. And then you have 0 thousands, 0 hundredths, you don't have to write. 7 tens, so that's 70, plus 70, plus 8 ones, which is 8. So wherever you have zeros, you don't need to put that in here. And there's your expanded form. So I hope that worked out. Okay, so now you have standard form, you have expanded form, okay, you understand about place value, and again, this is really handy tool, and it's in your workbook so that you have it to look at and work with anytime you need to. Okay, the next thing we want to do is look at how numbers compare. So let me move this over. This is how you get really good arm muscles, except you only get one arm that really gets muscles. Anyway, all right, so let's take a look at this next one, and it's 7 and 7. And then the next example is 7 and 10. We want to talk about how they compare. Well, obviously, we would say 7 is equal to 7. You could say that. You probably would say that, and you'd probably say, well, I'm done. I compared. 7 is equal to 7, or 7 is the same as 7. Okay, and remember, this is really important. Okay. Now, there are other symbols, but in math that we need to talk about. 7 and 10. Well, let's talk about that. 7 and 10. You might want to say 7 is not equal to 10. You might want to say 7 is less than 10. Look how important the is when you're comparing. It's in every one of these comparison symbols. You might want to say 7 is not equal to 10. And again, notice is again. All right, well, we have these symbols in math called comparison symbols, and let's take a look at them. So there are different kinds of comparison symbols. There's equality symbols, symbols that state you're equal, like the is equal to symbol. That's the only comparison symbol we have for equality, the is equal to. So this obviously would say 7 is equal to 7. And then you have other symbols called inequality symbols. And just to get some room here, I'm going to take this off the board. And I'm going to take a look at these inequality symbols. Let me kind of summarize all of them. Comparison symbols. And again, they're because you want to compare things. Yeah, comparison, compare, get it. Okay. All right, so you have equality symbols. And you have the is equal to. But now you also have these other great symbols called inequality symbols. These are symbols that state that things are not equal. So you have the is not equal to. And anytime you say not, in math, you actually take the symbol that means it is and just put a slash through it. So here's is equal to, is not equal to. Now I always do this a little backwards, okay, but is not equal to looks like that. Okay, and then you have the symbol is greater than. Is greater than looks like this symbol. Is less than. Which is this symbol. Then you have two other inequality symbols. You have the is greater than or equal to, which looks like this, is greater than or equal to. And notice the or, because you can't be greater than and equal to a number at the same time. We'll talk more about that later. And then you have the is less than or equal to symbol. And those are your inequality symbols. Okay. So let's again look at this 7 and 7. You want to say 7 equals 7. That's correct. But it is also equally correct to say 7 is less than or equal to 7, because it's not less. 7 is not less than 7, but it is equal to 7. So you can say that. You may not want to say that, but you can say that. That is a true statement. And notice, because it's a comparison statement, we can determine if these things are true or false. And you could also say 7 is less than or equal to 7. Again, all you have to do is be one of these for this to be a true statement. So, I said that twice. Sorry. Let's say 7 is greater than or equal to 7. I stuttered. Okay. Now let's look at 7 and 10. Okay, again, you could say 7 is not equal to 10. You could say 7 is less than 10. If you wanted to change the order, you could say 10 is greater than 7. You could say a lot of things. You could say 7 is less than or equal to 10, because it is less than 10. You could say 10 is greater than or equal to 7, because it is greater than 7. Again, you only have to be one of these, and you only can be one of these. There's something in math called a trichotomy of numbers, which means that you can be one of three things with another number. You could either be equal to a number, less than a number, or greater than a number. Okay? So these are all the inequality symbols. Let's take a look at the real numbers again. Remember that the whole numbers and the natural numbers are all part of this big set called the real numbers. Okay, and no, there are no fake numbers, but there are other types of numbers that you'll come into contact with in the higher math courses. Okay, they're called imaginary numbers, if you care. Okay, let's take the whole numbers, 0, 1, 2, and obviously these numbers are also natural. Okay, and let's take a look at the inequality sign is less than. If we say 2 is less than 5, we can actually show that on a number line by putting a dot or a point on 2 that will graph the 2 or plot the 2, and we could also plot the 5 by putting a dot on 5. Now notice that the 2 is to the left of the 5. That's how we know 2 is less than 5, because as the numbers go from left to right, they actually get larger. The numbers get larger. So the numbers to the left are less than. So 2 is less than 5, and I could show that on a number line. Okay, now I'd like you to take a second to stop the video and do the next problem in your workbook that tells you to put comparison symbols into some different expressions. So the first example was 0 with a blank 12. We want all the different comparison symbols. Let's kind let's kind of review for a second what they were. That was the inequality symbols, which is the is not equal to, is less than, is greater than or equal to, is less than or equal to, or just the equality symbol, which is just the equals. Well, let's look at 0 and 12. To compare them, we see that 0 is less than 12. We also see that 0 is not equal to, oh, I did it again. Put that line the wrong way. Don't worry, I won't mark you off if you do that. 0 is not equal to 12. We could also say 0 is less than or equal to 12. Because remember, it's or, and 0 is less than 12, so that's why that's a true statement. For the second one, the two numbers you're comparing is 406. Remember, don't say and the number 400. Well, 406 is not equal to 400. 406 is greater than 400. And if you wanted to, 406 is greater than or equal to 400. So I could use any one of these symbols. You might think it's silly to use this one, but we're just trying to make you understand that you can use this one. Okay? And the last one is the one people have the most problems with filling in. Because everybody wants to say is equal to, 50 is equal to 50, but there are other symbols you can use. You can use 50 is less than or equal to 50, and the reason that's true is because it's equal to. Remember, it's got to be one or the other. Or you could use 406 is greater than or equal to, oops, 406. Look at that. I'm reading the wrong problem. Don't do that. That would be wrong. Let's take a look at 50 again. 50 and 50 is what we're comparing. And you can say 50 is greater than or equal to 50. And again, that is correct because we have that equal to there. So any one of those symbols would work. I hope that went okay for you. Okay, now if you take a moment and stop the video and go to your workbook and do the last problems that are on there that show up with the chart. Okay, I hope this chart was easy to read and understand. Let's take a look at this. And the whole purpose of this chart was to make sure you understand how to read a chart or a table and to also review some of the things we've done in this lesson. So let's take a look at the first question. The first question says, fill in the blank with either expanded form or standard form. The number of votes in column 2 are given in what form? Well, notice that they're written down like this, 2078, and so on. That is called standard form. That is not expanded form. That is standard form. A little FYI, expanded form for this would be 2,000 plus 70 plus 8. Okay, that would be expanded form. Number two asks you, what is the place value of the 8 for the number of votes received by Mr. Olson? Well, let's take a look at Mr. Olson. Mr. Olson is 2,078, and you want the place value for the 8. Well, the place value for the 8 is the ones place. And number three, write in words the number of votes received by Miss Lee. Let's take a look at Miss Lee. Okay. Notice Miss Lee has 3,760 votes. No and, remember. 3,000. Remember, there's a comma, so I put a comma there. 700. No comma, because there's no comma there. 60. Okay? Almost done with these? All right, let's take a look at 4 and 5, the last two. Write the number of votes received by Mr. Barone in expanded form. So let's go to Mr. Barone and write him those votes in expanded form. So Mr. Barone is 2,000. 780. So 2,000 plus 700. Oh, that's a bad comma, huh? 2,000 plus 700 plus 80 plus 0, so I don't have to write the 0. So that is expanded form for Mr. Barone. And that was question number 4. Okay, for question number 5, it says who won the election, which is probably the most important part of this. Well, we have to just compare all those numbers and pick the highest one. Well, the largest number is Miss Lee with 3,760 votes. So that wraps it up for Mod 1, Lesson 1. Join us next time for Lesson 2, where we do addition of whole numbers and perimeter.